In standard geometry, finding the sine or cosine of an angle requires a calculation. You take the length of the opposite or adjacent side and divide it by the length of the hypotenuse. But if we set the hypotenuse to exactly 1, that division disappears. Dividing by 1 leaves the original value unchanged. Sine becomes the length of the opposite side, and cosine becomes the adjacent side. We can standardize this by placing the triangle on a coordinate grid inside a circle with a radius of 1. On this grid, the horizontal leg measures the x-coordinate of the point where the triangle touches the circle. The vertical leg measures the y-coordinate. On the unit circle, you no longer need to calculate. A point's x-coordinate is its cosine, and its y-coordinate is its sine. At 45 degrees, the point sits exactly halfway between the horizontal and vertical axes. Symmetry requires the horizontal base and vertical height are equal. By the Pythagorean theorem, x squared plus y squared equals 1. Solving this reveals both coordinates are exactly root 2 over 2. We find values for 60 degrees by starting with an equilateral triangle where every side equals 1. Cutting it in half creates a right triangle with a base of 1/2. The Pythagorean theorem gives a height of root 3 over 2. Based on that same triangle, we can determine the coordinates for 30 degrees. When the triangle rotates flat on the x-axis, the geometry remains identical, but the short base and tall height swap positions. These special angles are exact geometric measurements derived from standard shapes. As point P travels counterclockwise around the circle, we track its vertical height over time. As the point completes a full rotation, the circle's geometry creates the repeating pattern of the sine wave. To find the tangent, draw a vertical wall touching the circle at x equals 1. Extend the radius from the origin through point P until it hits the wall. The height of this intersection is the tangent. At 90 degrees, the radius points straight up. Because it is parallel to our vertical wall, the lines never meet, leaving the tangent undefined. These trigonometric functions represent physical lengths and real-world shapes. As point P orbits through the grid, the triangle shape remains the same. Only the coordinates change between positive and negative values based on the quadrant. Removing the coordinate grid reveals the triangle that governs these relationships: a base of cosine, a height of sine, and a hypotenuse of 1. Applying the Pythagorean theorem to this triangle gives us the identity: cosine squared plus sine squared equals 1. This relationship dictates how physical objects move. In this Foucault pendulum, the side-to-side swing follows the oscillating curves of the unit circle. It also powers digital space. Computer monitors display 3D rotations by using sine and cosine to calculate new coordinates for every point on a wireframe. The unit circle translates the geometry of a single triangle into the waves of a pendulum and the rotations of a digital grid.